We're going to use Duracell because that's hilarious. It's the Energizer Bunny. It's
Yeah,
or it's
yeah.
Energizer.
the old Duracell Energizer
Yeah.
Bunny.
Well, whatever it is,
Great
we're
mascot.
going to use that one.
Welcome to Tell Me About It. This is the show where I interview various professionals to get insight into their daily lives on the job. I'm your host, Josiah Smith, and with me today, I have Connor Bailey, fire protection engineer. So, Connor, if you could just introduce yourself and give me like the kind of 2-minute elevator pitch, Indeed job board description of what you do.
Sure. Yep, I'm Connor Bailey, fire protection engineer, as Josiah said. The sole duty of my job is to partner up with architecture and other engineers, other consulting engineers, and help design a building that is code compliant. And my portion of that is the fire protection systems, fire alarm, fire sprinkler, and the life safety, egress, code consulting in that portion.
All right. Well, there's a lot there, so this is good. We'll have plenty of content. How long have you been in the field?
I have been in fire for about 8.5 years now.
Okay. In fire, not on fire, right?
Yeah, exactly. In the fire protection world. So
in the fire protection world.
Consulting for 4 years and working for a fire sprinkler company for 4 years before that, or 4.5.
Okay. What did you do in the 4 years prior to consulting?
So I was working for a contractor who would design and install sprinkler systems.
Okay.
And so I was designing more of the nuts and bolts, the exact pipe routing, ordering the material, coordinating the install effort with our field team and the general contractor on site, and basically starting from a plan, getting a permit, getting approval, ordering the stuff, seeing it through to being delivered, and then our guys would be installing it under the general contractor.
And then consulting now, what's the differentiation between what you did and what you do now?
There's a very thin line.
Okay.
The difference is thin. So now what I do is I design fire protection intent documents. So when I was working for the subcontractor, we would look at these intent documents, and the intent documents say, hey, this building is going to be this shape, this height, this construction type. We're going to have this type of sprinkler system, this type of fire alarm system. You're going to have these different components in the stairwell over here. You're going to have other stuff over here. And it kind of prescribes the project. So then the subcontractor gets it, and there might be 4 or 5 of us putting a number or a proposal together for that job, and it just helps everyone get more accurate on their proposals and bids, and so that the engineering consulting team that designed the building is getting what they have designed it for. Now I am designing the overall system more holistically. Not always drawing the finer details, the exact pipe routing, the sprinkler head locations, the pull stations, all that.
Gotcha. So what you did before is like you design it, and then it goes from your desk to the building that's being built, and then now you're maybe like a step before that, where you're like, this is the system that we need, and this is how it's supposed to work. Now somebody else draw it up and then put it in. Yeah. Am I understanding that right?
That's right. We could be an entire year or 2 before a building ever gets built. Or sometimes it's faster paced than that. But if you think of like a large stadium, like here in Nashville, the Titan Stadium is getting built, the new one.
Yeah, go Titans.
Go Titans. There was, as you can imagine, lots of different big picture drawing packages that had to come together to demo the old parking garage area, demo the old parking lot, prepare the site, prepare the structure and all the things. And it's just a really long, drawn-out timeline of start to finish. So we're really well in advance looking for potential issues or In my industry, I look at water supply. So does the city have adequate water for you, for the sprinkler system, all of that. It's maybe one or two steps removed from the subcontractor whose duty is to look at our drawings and create shop drawings essentially so that they can install.
Okay, cool. So talk me through then your like qualifications to get to this point. Go through education, certifications,
Yep.
licensees, whatever.
Yep. So the credentials that I have, I am a professional engineer, and the subdiscipline that I took the exam in is fire protection engineering. So I am
Okay.
a fire protection professional engineer.
Okay.
There are several different professional engineering disciplines out there. Of course, you can imagine mechanical, electrical, civil,
Is
controls.
software in there? Is software part of that world, or this is more
There are,
hard science versus soft science type of thing?
no, I mean, they got electrical.
Yeah.
There's nuclear. There's a lot of different disciplines. I think they grow a little bit every couple of years. I don't know about that side, but fire
Okay.
protection is relatively new in the licensure scene, maybe in the
Okay.
last 20, 25 years.
Hmm.
Before that, you were having like a mechanical engineer design your fire protection systems, but now there's credentials to do this work.
Okay.
So, in order to get that certification, you have to go to a 4-year accredited engineering school. You have
Okay.
to work in engineering for 4 years under a registered professional engineer, gaining
Okay.
experience. They have to, um,
Is that the same as like a trade, like apprenticeship, or is just
similar,
or
yeah.
not? Is there a difference? It's similar.
Yeah,
Okay.
yeah. So it's not official. It's not as official with extreme documentation like you have with an apprenticeship. An apprenticeship program, they might put you through. You have to do all these workbooks. You have to get it signed by
Mm-hmm.
a supervisor, and you're taking weekly tests. This is
Mm-hmm.
more, hey, I'm working under you, Josiah. You're the professional. You're mentoring me. And then at the end of 4 years, I want to become licensed. And so I'm
Okay.
going to need your help. I'm going to need you to write basically sign a document recommending me for licensure.
Okay.
Um, so at that point, you have to get your references together, sign up for the thing, and then take a test. If you pass the test, fire protection is offered one time a year. So if you fail,
Oh,
you got to wait. You got to wait a
wow.
year, and then once you're licensed, you're a fire protection engineer, and you just have continuing education every so often, depending on what state you live in and what state you're
Sure. Okay.
certified in.
Oh, so you're a professional engineer in the state in which you live. It's not like a national type of licensure. We might be getting ahead of ourselves a little bit, but could you consult on a project that's out of your home state?
Absolutely.
Okay.
Um, so in building design, it's very different depending on what region of the country you're in, what state you're in, or even what city you're in.
Oh,
Each
okay.
state
Okay.
will have a certain statewide adopted building code. The most popular is the International Building Code, and there's other international codes that live under that. But if you're
Okay.
in Kentucky, they have addended that and made their Kentucky Building Code. And the
Hmm.
Kentucky Building Code reflects the International Building Code with differences. So each state will have different year editions of the code that they follow. And so you absolutely can practice in other states as a registered engineer, but you may, in order to get licensure in that state to actually seal a drawing, because we have a little seal with our credentials on it, our name and everything, and we have to sign over it. You can apply by committee to basically like reciprocity. Hey, I took and passed my test here in Tennessee. Hey, Kentucky, I need licensure there. Here, I passed the same test that you take in Kentucky. And they look
Okay.
at your references and they say, yep, you're good to go. And now you're registered professional engineer in Kentucky.
Oh, interesting. Okay. So you would have to do that each time you work on a new building that's in a state that you've not already gone through that process for?
In the commercial and industrial world, yes. So
Okay.
if Hilton Garden Inn is going to build a hotel in Wyoming, I'm going to need
Mm-hmm.
my professional engineering license in Wyoming. Now, if the
Oh,
United
okay.
States government is building a barracks in Wyoming and I am not licensed there, the United States government has different rules, and I can actually
Of
stamp it with
course.
any state as long as you're a professional engineer who has passed the fire protection exam, then you
Uh-huh.
can do that work. So it's
Interesting.
you have to, my company, we have several engineers with different licensures. I think I have 5 different state licensures. It's
Okay.
just applying and sending in a check.
Yeah.
It's not, there's nothing really to it. Um,
Okay.
but we can pretty much reach all 50 states,
Yeah.
um, or we can just
Is
apply.
there internal competition where you work then to like get as many states licensure as you can so that you can be added onto projects, or is it doesn't really work that way?
No, it's not. I work for a very small firm. It's not
Okay.
competitive like that. Um, if you need a state license for a certain state, just apply for it and get it. It's probably easier to just have the person with that state work on that project so that
Mm-hmm.
they can do it themselves, they can stamp it themselves instead of having to, figure that out other ways. Um, but it's actually kind of a pain to have licensure in let's say 50 states. Each
Mm-hmm.
state has different time cycles of when you need to renew. They have different numbers of
Oh.
continuing education credits. Some states
Mm.
have specific laws and practices that you have to study and get those credits. Like Florida has their own um, local laws course that you have to take every 2 years. It's only an hour, and the same for ethics. And that's just Florida. There's plenty of other
Mm.
states that do something similar. So,
So it'd be like a
yeah,
part-time job just keeping up with all your
yeah,
licenses if you were
yeah,
across all 50.
yeah.
Interesting. Okay. Um, so then you mentioned that you work for a small firm. Talk me through your kind of position there at that firm. Kind of give me the organizational chart and where you fall in there.
Okay. So, my firm has 8 people working there,
Oh, wow.
whereas my
8
previous
engineers or 8 employees?
8 employees,
Oh, wow. Okay.
7 are engineers.
Okay. Awesome. And the eighth is the owner.
No, he's an engineer. He's an owner.
Oh,
The 8th just
awesome.
didn't go to engineering school. He's considered like a designer. He's designing work.
Okay.
He's just not able to stamp and seal it.
Okay. Gotcha.
So in our company, there are not a lot of tiers of people. There's not a huge organizational chart. It's pretty flat. Each
Okay.
engineer also operates as their own project manager.
Oh,
So I'll have a project. I am responsible for all of the deliverables, all the drawing packages, coordinating with the client, understanding the schedule, chasing after change orders when things change, um, everything from start to finish. There are several of us that do exactly that. Then we
okay.
have the owner who he has other responsibilities. We also have someone who kind of has their toe in 2 things. He's an operational manager or operations manager, and he's also a professional engineer. So he's still very much doing some with design, but his focus is more on the operations. So procedural things, how we as a company operate, um, certain design nuances that we don't see often, but we see maybe twice a year, and we forget what we did previously. So it's like setting up these processes so that as a company we are consistent from one engineer to another, so that you're not getting a drastically different product from Connor as you are from Josiah.
Okay.
Um,
Cool.
yeah, that's pretty much the top down. Other engineering firms are a little different. You'll have your engineering interns, which are people who have graduated from an engineering school with their degree that have not yet passed the professional engineering test. So they're considered engineering interns. And then from there, you pass the test, you go into engineer. And then there's a few different routes that consulting engineers take. You can either go kind of technical, and you can move deeper into I just want to design and look at code all day and sit at the computer. You can also move into kind of management. I want to manage engineers. I think I'm better with people than I am with the code and numbers. I'd rather be overseeing 4 or 5 engineers and having a team. And then, whatever, once you get into management, there's other routes for that.
Yeah. So is it common, your situation there with a smaller firm, is that more common or less common in your field?
So fire protection engineers are very uncommon. It's very rare to have someone at your firm with that licensure. So at my previous firm, there was about 200 or so employees, maybe 100 of them were professional engineers, maybe 150. And I think myself and one other guy were professional or fire protection engineers.
Okay.
So the number of FPE, it's easier to say it that way. The number of FPEs are really small compared to the other disciplines. So it's hard to compare, like, is our firm really small? It is really small, but we have more professional or more fire protection engineers than you'd find at probably most big firms. So we're highly specialized in that field. So we get hired out by either architects or by other engineering firms that don't have a strong background in fire protection.
Okay. That was my next question. I was going to ask, like, does that make your market a lot bigger, since you're like, this is the one thing we do and we do it really well and we do it better than other options?
Yes, exactly. We know that fire protection is very dependent on other aspects of fire protection. So your fire sprinkler system is very related to the way you lay out the building and the life safety portion. Fire rated walls, fire barriers, number of stories, height and area, all of that, as well as your fire alarm system. At a regular firm, you might have an electrical engineer doing the fire alarm design, and he's not talking to the plumbing designer that's doing the fire sprinkler drawing, and he's not talking to the architect that's doing the life safety code consulting. So what we offer is the complete package where you have one guy doing all three and coordinating all of that with the architect, and you don't have to worry about something getting missed or I was unaware of that. I didn't know that the electrical guy was doing this, and this. It's taken care of.
So that would require then a lot of like broad knowledge in multiple disciplines, right? Like you need to kind of have an understanding of how plumbing engineering works, how electrical engineering works, in order to make sure that your fire protection drawings are actually doable. Am I tracking there?
Yep. So that's the industry. Right now, every engineering firm is drawing their documents in some kind of a software that can coordinate in 3 dimensions. So the architect and the structural engineer will develop a model. It's called a model, and you can look at it. It's to scale. It is exactly what it's going to be. If you draw if you want to dimension something out, how much room do I have from this edge of the hallway to the other edge? It'll tell you exactly 13 feet, whatever.
Wow.
So inside of that, you can reference other models. So each discipline will have their own model. So it's like a model within a model within a model, and we're all looking at each other's stuff.
And they just overlay on top of each other?
Yeah.
So you can see how it all... Okay,
so you can see how everything works. You can turn things off. Hey, I find plumbing is really in the way. I don't want to see it right now. All the fixtures, I don't care about that. I care more about the pipes in the wall. Well, I'll just turn off one layer. I'll just turn off the fixtures. Or I'll just turn off the text because the text is too big. Or
takes a bunch of space,
the ceilings are really annoying to look at. I know they're there. I'm going to turn them off. So then when I'm coordinating and drawing my fire protection, like the sprinkler piping, I can make sure that that corner where I've got that pipe is not hitting mechanical equipment plumbing,
Hmm.
rainwater leaders, electrical panels, anything. So I can
Yeah,
see exactly what's happening in that corner real time with all the other disciplines information in there without having to pick up the phone.
that's cool. That's really cool. And is that the is the would it be like the overall project manager? I guess the architect would share that file out to every firm that they've got working on the project, so that
Yeah.
they're all looking at the same one.
Yeah, so when I started in consulting, it was common that you would have a local model, a model that lived on your machine, and
Mm-hmm.
you would design within, and then you would send out your model, and other people would download it and reference it. So
Right.
you can
Yeah.
imagine that could be pretty frustrating if you've done a lot of work, you send it out, and you find out, shoot, everything is hitting everything else. So
Yeah.
now, which this is, good and bad, now most of our models are in the cloud. And
So it's
so,
like a live service. Like you're throwing a pipe in here while the electrical engineer is putting an outlet there, and whatever, whatever.
yep.
That's
So you
awesome.
can work in it at the same time as another 100 engineers that are also working in it. And as long as you hit the synchronize button, you can sync up your progress and it just spits it out live onto the other models. And they can see, oh, shoot, yeah, okay, he did move that, thank you. Or
Yeah.
I can call my architect and say, hey, that door is really in a bad spot. In fact, for egress, you have too many people that need to pass through that door. You need to flip the door swing. It needs to swing the other way.
Oh, okay.
Sure, it takes 2 minutes instead of having to export your model, email it over, some file sharing
Yeah.
service, then you got to download it and all that. Nope. You just both hit sync and you've got the update. It's
Wow.
really effective.
So, talking collaboration, then, is it? How do I ask this? How well do various engineers get along? Like, is it common for everyone's like, hey, our goal here is to get this building going, so we're all going to be accommodating and gracious with one another, or is it more like, no, I'm the fire protection engineer, I'm putting my thing here, you need to work around it, and or the plumber or the electrician or whatever. Is there any kind of like conflict that is normal or natural that comes about, or is everybody pretty well on the same page?
So, in most cases, everyone's a team. Our end goal
Okay.
is to build this building. So
Yeah.
we have to work together. Where you see that type of conflict is on the job site between the trades that are putting in the stuff. So if the
Okay.
fire sprinkler, excuse me, if the fire sprinkler guy shows up and he starts installing pipe, and he doesn't ask any, whatever, and then a week
Yeah.
later the mechanical contractor comes to put up some duct work and it's in the same location that they would have been, they
Yeah.
get mad at each other,
Sure.
right? Yeah, it's
Yeah.
crazy. It's like, but I was going to be there.
Right.
But I was there first.
I was there
So
first. Yeah.
so that happens on the job site. But if you have a really well coordinated model,
Mm-hmm.
there shouldn't be these conflicts. There's a thing
Okay.
in the industry which is like a more advanced level of design that
Mm-hmm.
utilizes something called BIM coordination,
Okay.
where
BIN.
BIM
In as in Nancy.
as in mother
Okay.
or Mary.
You got Mike. I don't know.
Yeah. So BIM, I don't know what it all stands for, but it's everything is drawn out. You can see where clashes are happening. So you can see that your pipe has a hanger on it, and that hanger is going through a mechanical duct. So either you need to move the hanger, you need to reroute the pipe, you need to coordinate. So everything, when you show up on site, it should just go in the way. I mean, you've proven in the model that it can fit,
Yeah.
and it's a model, so things are different in
Sure.
real life, and maybe
Yeah.
somebody put something an inch off versus where they should have been.
So the human element comes in, right? Like you've got the software that you can triple check, but then once
Yeah,
you concrete something in, it becomes a little a little
yeah,
more difficult to redo.
yeah. A good general contractor is driving his subs on the job site, driving
Okay.
the schedule, driving the install, driving the quality. If something looks wrong, they are on them. Like, hey, that is crooked. You need to
Fix
straighten
that.
that
Yeah.
up. Or, hey,
Okay.
you can't be there. I need you to take that down. I told you can only work in this zone over here
Uh-huh.
because I've got the doors and windows guys coming in today, and they're going to be right here where you are. So You need to
Okay.
relocate. So on
Yeah.
the engineering side, conflicts are not they're not massive.
Mm.
Everyone kind of stays in their own lane.
Mm-hmm.
You kind of get in trouble when you start doing work for other people. So if you start thinking too much, like if you start thinking too much into the electrical engineering, hey, I need this, 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 and this from you, that's not going to be received well. It's
Yeah.
probably better to
So
say,
like stay in
hey, this is
your
my
fire lane.
equipment. This is the electrical ratings. It's a 480 volt, three phase, whatever. They can
Uh-huh.
they can then pull their power and bring it to it.
Yeah. Okay. Interesting. Um, okay, so give me you've kind of covered some of this already, but if you could just real quick give like your um, kind of your major roles and expectations. So if you clock in on Monday through Friday or whatever your work schedule is, what is it that you are getting paid to do? And if you don't do it, then you're not doing your job. And then kind of follow that up with those minor responsibilities. Like if I get my major tasks done, this is what I do. And then from there, we'll jump into a little more specifics.
Okay. So we plan about a week ahead, so that when we show up on Monday, we already know what we need to do for the week. We have our tasks ranked from critical down to low, or obviously critical needs to be done first, and then as you have time for it, you can get to those more minor tasks.
Do y'all create those lists at the end of the week, or who makes
We
those?
create those lists for ourselves on
Okay.
Wednesday, and then
Okay.
they are assigned to the engineers on Thursday.
Okay.
And you kind of try to stay within your bounds of however many hours you have to work that week. And you can also assign work to other engineers. Like, hey, I'm really booked. I need help with this. I need support item. I need Josiah to work 6 hours on this task, and here's the exact task I need him to do. And
Mm.
Josiah, you only had 32 hours, so you can handle another 6 for your 40-hour
Okay.
work week.
Yeah.
So then you can get assigned that time. Anyway, that's a little granular.
No, that's okay because
We
I
come
mean,
in
that's
with
the kind of detail
tasks.
that we're looking for, right? Is like, what does this
Okay.
actually look like that you're doing?
Yeah.
That's exactly what I'm looking for.
So I sit down on my computer, and if I have several projects that I'm working on at one time. It
Okay.
would be great to just work on one project from start to finish,
Hmm.
but it doesn't work that way. There's not enough money in
We got to
each
keep the money
project
flowing.
to support
Yeah.
to support an engineer's salary to just sit on that project for a year.
Sure.
So you're juggling multiple projects with different timelines, different deliverable schedules, different Teams meetings you have to be on, or Zoom or whatever. So I'll look at my calendar and I'll see what meetings I have, and if I need to prepare anything for those meetings, whether I'm presenting or just need to be available if a question comes up. Those meetings that I just need to be available, I can work in the background. So
Mm.
that work looks like me pulling up the model for whatever project I'm working on, and I am evaluating what needs to be done, and I am starting to analyze the flow of the building, the use of each room, and applying
Mm.
different symbols and lines and circles and notes to the page,
Okay.
so that over a series of days working on it, I can have a completed drawing that tells my subcontractor this is the type of fire alarm system you're going to install for this building, because I've already done all the code research and looked up all the devices that need to be in there. This is the type of circuit, these are the types of panels. I've coordinated with the electrical engineer to bring power to it, all the stuff. So my day-to-day big tasks are to develop my drawings and then to provide support or input in meetings.
Okay.
Smaller tasks would be working on improving processes or helping others with their tasks or covering meetings for other people, um, maybe calling on your architects and asking questions or seeing what upcoming work is about to come in so you can kind of predict your workflow for the next week. But the week goes pretty quick. there are a lot of projects to juggle, and so you might work on one project for 2 days and then you jump off of it and you work on another project for the rest of the week. Or
Mm.
maybe you are only parked on one project for that week because you have a deliverable at the end of the week that you need to have that model in a place to where you can plot PDFs of what you've done and upload it.
Mm.
Um,
So if you're doing like a 15, 20-story building or something, do you design by floor? Like, I'm going to start with the ground floor design, move up to the second design, or is it more fluid in how you do the designs?
so, with a very tall building, right?
Mm-hmm.
The most demanding, um, from like a fire sprinkler perspective, would be the highest floor. It will
Oh,
take
sure. Okay.
me
Getting water
the
pressure.
most water pressure and yeah, pressure to get to the top because I'm losing pressure every foot I go up.
Sure.
And so I will do a top down approach. I will
Okay.
start at the top. I'll find out my highest demand in the entire building, which might be the top, it might be the first floor, whatever. So I got to look at the whole building, find out where the most demanding part of it is, and then I can work down with the larger pipes that maybe they just run water all the way up to the top, and then from there it branches out to the different rooms and everything.
Okay. Yeah.
And you'll find out, hey, I need a fire pump. I need a pump to add pressure because the city's
Mm-hmm.
pressure isn't adequate for the top floor. So then
Hmm.
I need to design the pressure rating on the fire pump and how much water needs to go through it and everything. So at the end, you will have gone through every single floor.
Mm-hmm.
But the best way to do it would be, hey, I've got to cover the big stuff. I need to make sure I've got enough water on day one. So I need to find the most demanding areas in the building and then
Mm-hmm.
design to that.
So then it's really important to know what the like purpose of the building is. Like, you need to know, is this an office building? Is this a hotel? Is this I don't know, a warehouse? Like, you have to know,
Yeah,
how detailed do you need to know what is going in the building in order for you to do your job well?
very detailed. Um,
Okay.
it's all about the details. So
Oh.
if you have a storage warehouse,
Uh-huh.
what are you storing? How
Yeah,
are you
okay.
going to store it? Is it good?
Batteries.
Okay, batteries. What type of batteries? What's the chemical makeup of the battery? How are you going to store it? Is it going to be in
I don't know. What's a dangerous battery to store? Tesla batteries.
lithium ion? Okay, great. What state of charge are they going to be in? Is this man?
Okay.
So you need to know everything.
I like this.
Um,
Yeah.
new products like lithium ion batteries. It's really going through fire protection. It is really changing for this product.
Uh-huh.
As you've seen on the news, a car will catch on fire and they can't put it out. It's like, whoa,
Mm-hmm.
what are we going to do about that? Um, and so there's been a lot of test paperwork studying these things and how to protect it from a fire. So what they found is the higher state of charge, so like your cell phone, 0 to 100, the higher the
Mm-hmm.
state of charge, the harder it is to put the fire out.
Okay.
And then,
That makes sense in my
yeah,
small
there's more
brain.
energy,
I get
there's
that.
more chemical
Yeah.
capacity for uh, a fire, a runaway fire.
Sure. Yeah.
So it's kind of understood that this stuff is very flammable if it's in a high state of charge. The Department of Transportation has stated you can't transport these things higher than 30% state of charge because
Okay.
we want it to basically mimic other types of products that are commonly shipped around, like plastic.
Uh-huh.
So with this warehouse example of batteries, if they're producing the battery or if they're just storing the battery, it's two very different processes.
Mm.
If they're storing these batteries, we have a lot of questions for them. State of charge would be one of them. How are they storing it? Is this going to be
Mm.
stored on the ground? Is it going to be on little racks that you move around and there's only 3 of them stored high? What's your total height? How high are you going to store it? Are they going to be in big cardboard boxes? Because cardboard boxes give you a different fire than if it's unpackaged. If it's
Mm-hmm.
so, and that's really to cover your risk, because if you go in as an engineer and you stamp that drawing and you say, this just needs a sprinkler system. Any old kind will do. And that
Mm-hmm.
building burns down and somebody dies, they're going to look at the design. They're going to look at what happened here. Well, that was an
Interesting.
inadequate design, and this guy put his name on it. He stamped it,
Mm-hmm.
and it cost millions of dollars and lives. So it's very important to get the details right.
Interesting. Cool. Well, that actually let's keep going on that track there. Walk me through in as much detail as you can. Let's pretend like I am a battery producer and I've hired your company. Walk me through. I've hired you to. We're breaking ground. What's the process from your perspective?
Okay. So that battery maker, we're going to use Duracell because that's hilarious. It's the Energizer Bunny.
Yeah.
Or it's
Yeah.
Energizer.
the old Duracell Energizer Bunny.
Yeah. Well, whatever it is.
Great mascot.
We're going to use that one. We're going to use
Okay.
Energizer now.
Okay,
So
cool.
Energizer says, "Hey, I've got a lot of money. We just bought this land in Arizona, and we need to build this plant to store our batteries."
Mhm.
Okay. That's their step one. Then they go to an architect and a general contractor. The architect's going to design the building. The general contractor is going to build the building.
Okay.
So you can get hired by the general contractor. Me, like the consulting engineering firms, can get hired by the general contractor or by the architect.
Oh, okay.
So by the time it gets to me, they have an idea of what processes and uses are going in that building, and they have someone who's prepared to build it.
Okay.
So that doesn't mean I just get a box and it's like, go. I'm going to have a lot of questions for the owner, for Energizer, to define what they're doing. I'm also going to have a lot of input based on important things like how high the building can get. You cannot, in the fire sprinkler world, you can't just store everything and protect it just from the ceiling. If the ceiling is too tall, that's an issue.
Okay.
You're too far away from the fire, you're not effective, your sprinkler heads won't activate, all these things. So
Are these in-person meetings that you try to have with if I'm Energizer, are you trying to fly out to Arizona to talk to me, or is it Zoom calls?
yeah.
Really, like several meetings, so you're just trying to run through them?
So a big high dollar project like a battery manufacturing warehouse or battery storage warehouse, I will personally attend like an in-person kickoff meeting. That
Okay.
kickoff meeting is going to set the schedule. It's going to set the expectations. It's going to lay out the project. It's going to get you to meet all the other players. Hey, this is our GC. Hey, this is our electrical engineer. This is our mechanical engineer. This is the architect. These are the names. This is your contact list that you're going to be working on. This is the team. And so everyone's going to get a chance. We're going to do like a very rough meeting or pull plan meeting where you're kind of saying, hey, if I start at the end, I've got a finished product, then that means 8 months before that, I need this. And 2 months before that, I need this. And you're kind of back planning to where you're kind of
interesting.
figuring out how long this project will take. So after that, I will not be attending every single week in Arizona. That would be very inefficient and expensive and not very effective. So I will attend weekly or bi-weekly or whatever they want, virtually attend these meetings. And I will contribute, I will ask questions. There is a formal process of getting information from the client called an RFI. It's a request for information. A lot of times you are sending in written statements of RFIs. Hey, I need to know how tall you're going to build this building, or how tall you're going to store this product. Is it going to be in racks? And you can ask a million questions to get your answers. And once you have the answers, that's in writing. That's kind of your guideline. That's your legally
That's more
binding.
covering yourself kind of stuff. I designed it this way because they told me this is what they were going to do in the
And
building.
if they decide to change it, things change all the time. So
Sure.
we can react to that. But it might be a cost impact. It might be too late. They might not be able to do it. But having it in writing is it's very important, so that you know what's going on.
Yeah.
In a lot of projects that are bigger, you'll get something called a scope of work, or a RFP, request for
Mm-hmm.
pricing, and inside it'll
Mm-hmm.
be a written statement of the project and what you're responsible for. So then when you
Hmm.
show up, you actually know what the project is. It's not learning for the first time.
Yeah. Yeah.
So that's kind of um, that's the meeting process. It's in person, it's virtual. There's other required in person meetings, especially for federal work, where you
Mm-hmm.
have to go to these design review meetings in person
Yeah.
occasionally, and it coincides with your different deliverables.
Yeah. So, okay, so then let's take it to the next step then. So, I'm storing batteries that'll be used for, I don't know, kids' carts, like the little drive around Jeep or
Yeah,
whatever. And I'm going to store those in cardboard boxes on racks.
sure. Okay. Yeah, we can do that.
Okay.
I'm sure that they've done it somewhere.
Uh huh.
That's not new. That is very doable. We can define, there are tables and tables inside of your code manuals that are taking products like that and
Hmm.
relating it to a hazard. And so
Okay.
your your little car battery might be similar to wax candles. I don't know. It's a dumb example. It might be similar to beer. It might be similar to
Interesting. Okay.
cardboard flats, like before they've
Uh huh.
assembled it into a box. And
Uh huh.
so once you have the hazard, you can design a sprinkler system to meet that hazard,
Okay.
meet or exceed. So, yep, Mr. Josiah, you've got these cars for your awesome cars. Here's the different options you have. You can store it on the ground and pile these boxes on top of each other, and that's called solid piled. It's very creative. Solid
Yeah, I
piled,
like that
or
little
you can,
on the nose. We like
or
that.
you can do rack storage, and you can put it on a
Okay.
rack. We need to know how you're going to do it, and we can do it however you want.
Okay.
We're very flexible. If you want to do some rack, some solid, cool. We just need to know, and we can figure out the different design hazard or design criteria to meet what you want.
Okay. So take me into that design process then. So I've given you the answers to those questions, let's say. Now it's time to design. Is that right? So
Mm-hmm.
you attend your meeting, you ask your questions. I've given you all the answers, and now you go.
Go. Yeah.
Okay.
Yep.
Walk me through that.
Yep. So um, usually the first step is finding the most hazardous area of the building, kind of like with our high rise, right? We
Yeah.
knew that
Okay.
the
Uh huh.
highest point is probably the most demanding on the pressure. Well, in a warehouse or a big building, I need to know, is there like a chemical storage, room over there in the corner right next to
Mm-hmm.
the offices? Or is the highest demand only the offices? And so once
Hmm.
you kind of have your worst case, highest, you can kind of work back. So
Yeah.
I know that you're storing the batteries here, but on the side of this warehouse, we're going to have a two-story office. Very common. You're going to have bathrooms, you're going to have conference rooms, meeting rooms, janitor's closet, whatever. That's a much lesser hazard than storing batteries. I mean,
Yeah.
what do you have in an office? Some chairs, table, like what is there to
Maybe
really,
a copier.
yeah, what's there to burn, really?
Yeah.
So you need less water over there. You need smaller sprinkler
Mm.
heads in those areas. Now, in these areas with stuff that is going to burn a lot, you need bigger sprinkler heads with more water available. And so your pipes are bigger. And so I'm designing the size of the pipes and the size of the fire pump based on the worst. So over here, I might need 8-inch diameter pipe and 2-inch diameter branch lines. That's like the
Mm-hmm.
branch line is just a pipe with sprinkler heads on it.
Oh, okay.
And then over in the office, I'm going to have a much smaller, I'm going to have a 2-inch pipe and 1.25-inch branch lines to those sprinkler heads. And
Hmm.
so it's going to be two very different systems, but we're doing the same thing. We are assessing the
Hmm.
hazard based on conversations we've had, based on the use of the room, based on what's in it, how it's being loaded, and then we are using our codes that tell us for that type of use and hazard, this is the type of sprinkler system you need to put in. This is the amount of water, they call it density and area. So this is the density of water per square foot over this much square foot that my system needs to be able to provide.
Yeah.
Is
it always water? Are there other fire protection like alternatives, or there's just nothing better than water at this point?
There are other systems. For a big warehouse, there is no alternative, right?
I guess it's gonna be water.
It's water. Water is cheap. Water is effective at cooling a fire. It's effective because it's readily available. Our cities already have water systems underground, so you're going to use water.
Yeah.
Now, if you have a library at the Library of Congress, and they've got these special documents that they don't want to get wet if there's a fire, but they also certainly can't afford for a fire to happen and just burn the stuff up. So what do you do? Well, there's other stuff they call it special hazards systems or clean agent systems that use a special chemical that does not harm your special books or your electrical equipment, your server room, but it suppresses a fire. It chokes it out. So there are some options. You can also use CO2. You can literally choke the fire out with CO2. That's more local application, smaller room. Don't think big warehouse. Think server room. Think your historical documents room, or just if you have something that you as the owner have decided, this is really important for me not to damage. There you go.
I'll do
something else.
Yeah. Because like movies make us feel like that kind of stuff is really common. Like, ooh, we're gonna go in here and they could pull the fire alarm and then we all suffocate and die, right? But that's pretty atypical.
Pretty atypical. That scene where you walk into the glass vault and the bad guy has pulled the alarm and then everyone dies instantly. Yeah. It's not quite that dramatic. We need to talk about other movie stuff too with fire protection. There's alarms, there's a delay. It takes an amount of time before you replace all of the oxygen with the other agent. There are emergency buttons on the inside that you can press to stop it so that if you're stuck inside, you don't die. There's a lot of fail-safe so that this is a safe system. It's not so dramatic.
Well, I guess that's to be expected, but kind of a bummer to hear.
Yeah.
Okay, so take me back to the design. Talk to me about the programs, systems that you use to do the design. What does it look like if you're sitting at your computer making these designs? Okay. Kind of paint that picture for me.
Yep. So a lot of what we do is reading code, and so you're not going to really see that on the drawing. I'm going to be flipping through different codes for different things. So if I have a standpipe system, there's a code for standpipes. And I'm going to have to read and say, oh, I need this size, whatever, blah, blah, blah. What does it look like? We have a program called Revit, which is the industry standard. There are different editions of Revit. So your project will select whatever edition of Revit, and everyone in the whole project will use that. That's the modeling software where you can upload or download a model that someone else has created, and then you can start adding things to it at very specific places in 3 dimensions. So you can select the pipe icon and start drawing pipe, or you can bring in a smoke detector. Let's say you're doing smoke detector spacing and you need to actually draw it. You actually can click the smoke detector button and start populating the model with everything. So design is a lot in fire protection is done out of the model, and then you're adding code references and you're populating tables. Hey, these are the different hazards. You've got light hazard in this office and bathroom, but in this janitor's closet you have ordinary hazard group 1, and that means something to a sprinkler contractor who has to design it.
Okay.
So yeah, you go through everything. So you've got your sprinkler, you've got your alarm, and then code consulting is very interesting. We haven't even talked about it yet. It's a really big part of building design. You cannot build a building as big or as tall as you want. There are limitations. There are different types of construction. When you see someone building a house, they can use, most commonly, is wood framing. Commercially, you see more like aluminum studs and non-combustible components. That's a different type of construction. You know, you've got your type 5, which is your wood and stuff, and then you've got other types that are designated by what you're doing. They have different properties. They have different fire ratings.
Where I live in Arizona, all these warehouses that are going up are all concrete. Like they lay out this big concrete slab, and then have these big concrete walls, and then they set them up like Legos. It's
called tilt-up construction.
There you go.
Yep, they literally will pour a concrete pad on the ground, and then they will grease it. They'll put down some like releasing compound or a big old sheet of plastic, and they'll frame up these new walls, whatever the wall is going to be, with whatever texture you want. Or whatever window holes you need in it. They'll box that out. And then they will just pour that sucker full of concrete and rebar and whatever. And then they do it enough times, then they take a crane and they lift it up. It just pops right off of that other slab. And then it looks like they've done nothing for 6 months, and then you have a building.
We've seen it.
Very cool.
Yeah, it is really interesting. And so I imagine there, I mean, concrete's not going to burn, right? So then that would probably change the fire protection approach as well, but then depending on what's inside the building, I guess.
Yeah, it more affects the life safety part, not so much the fire sprinkler, because if you put your lithium ion batteries inside of a wood building versus a concrete building, you're going to have the same sprinkler design.
Oh, okay.
Because you are protecting the floor, not so much protecting the building. You're protecting the floor and the contents so that you're not spreading a fire.
Gotcha.
But as you can just tell, it is safer to be in a concrete building more oftentimes than not than in a wood building when something's on fire. I'd rather be in the concrete building.
Yeah. That makes sense. Okay. So continue with design then.
So for fire alarm, you have main fire alarm panels, and then you have sub panels from there. And so you are working with the architect to say, hey, I need this much space for my panels. I need a room 8 foot by 8 foot. And they'll build you a room 8 foot by 8 foot, whatever you want. And I mean, not whatever you want, but whatever they have space for, they will build you that room. And you start populating that stuff. You start putting it on the walls. You start spacing it out. You start naming the panels. These are real panels. It's just not just a box on the wall. This panel is an actual product sold by a vendor that somebody can now say, okay, they want that Potter panel, or they want that Simplex panel, whatever. And then you're going through the rooms and adding your pull stations, like what you would pull near an exit to activate the fire alarm, saying, hey, there's a fire. Pull that. Those aren't just located anywhere. There are inside of code. It tells you where to locate them. So we start putting those on the wall where those are needed. We start putting up visual notification, like strobes.
Oh, yep.
And those have different spacing requirements based on how much power you put to it. They have different ratings, so you might space them every 30 feet. You might space them every 75 feet. It just depends on what you need for that area.
Yeah.
Then you add other devices. So then at the end, you've got a plan. You've got each floor full of the system, and it works together. You've coordinated it with all the other trades, and then you do the same for fire sprinkler. You you have determined the hazards already, and so now you need to bring water from underground into your building, above ceiling, and out to your systems. And there's limitations on how much square footage each system can be. So you can't just have one pipe feeding the whole building. Even if you could get it to calculate that way, there's just a restriction on how much floor space that system can be designed to.
Sure.
And so your design efforts might be drawing the piping from where you come in from the underground to each of these different zones, and sizing it. And you have to do hydraulic calculations based on the demand of that area and how much, based on the qualities of water, how much pressure loss happens through that pipe, through that size of pipe, through that elbow. Maybe it turns 5 or 6 times before it gets there. That's added pressure loss, like a kink in a hose. You lose pressure. And you're recording all this stuff, all the calculations, and you are proving this works with this water supply to protect this building, designed this way. We have fire sprinklers everywhere. We have the piping everywhere. We have your fire pump here with all of its details. We're prescriptively writing notes that apply to this building. So it's a general notes section. And hey, in this building, you have to use this type of pipe for this size branch line. Boom. You have to use whatever. It's just all prescriptively written and visibly on the page. So then at the end, you go through multiple rounds of this. It's not, I sit there at a computer, I work for 8 days, and I turn it in. That would be great. It doesn't work like that.
Yeah. But it goes through revisions as things change in the design of the building.
There's different stages of design. And so it will start at 0% and then eventually end up at issue for construction, 100%.
Okay.
You only assign and put your stamp on the drawing that is issued for construction. So everything before that is just a progression of the design until you get to the end.
Okay. So, as I've kind of understood as you've talked about this, it seems like the sprinkling of the building is really kind of like the main part. Like that's the most important thing to take care of. But you've mentioned before things like fire breaks and I don't know, different kinds of walls, different kinds of whatever. Ingress, egress, I heard you mention as well, which are fun words. So are those also a part of your job in your design, or is that more up to the architect?
A lot of times architects do that work. But in the federal world, the architects are not allowed to do that work. It has to be done by someone who. This is crazy. The code consulting and life safety. It's good. It's good for business. The code consulting and life safety drawings have to be developed by someone who has taken and passed the professional engineering test for fire protection.
Nice.
In the commercial world, that's not the case. A lot of times the architect is just doing that. So that is my job. Most of my job is the code consulting, life safety side. Another big part is sprinkler and alarm. We've kind of focused on sprinkler and alarm because everyone's seen it. You can look at it. It's generally
like, oh, that's
point to the
sprinkler.
ceiling. Yeah, that's that. The other stuff is more of your passive building design.
Okay.
So there are lots and lots of codes that go into building a building. What construction type you need to build your building, what the occupancy is. So what is this building? Is this a business? Is this a dormitory? Is this storage? Is it a factory? Is it hazardous? Is it industrial? Is this a prison? There are so many different rules based on what the occupancy is. And then
does the rules on, I'm sorry to interrupt there, but you said dormitory and you said prison. Do the rules change? Is the code different from prison to dormitory?
Oh yeah.
Fascinating.
In a dormitory, you're free to leave. In a prison, you're not.
Right.
So there's a
no kidding.
You can check in anytime. So as you can imagine, it's a very different animal, and so it's very different design.
Sure.
So based on the occupancy of the building and how tall you want to build it, there are different rules that you have to follow. What that means more practically is you may need 3 staircases instead of 2 because you have this many people on each floor. So that will drive your building design. Hey, I've
Yeah.
only got 2 staircases, but I just looked and you've got 150 too many occupants than what's allowed for just 2 staircases. We need to add a staircase somewhere. So then you're adding a staircase. That's a huge impact, huge
That feels
cost.
like a major
That would
change.
be a
Yeah.
big miss if the architect had not considered the 3rd staircase. That would be huge.
Yeah. Yeah. I'm thinking like multipliers wise, like adding a staircase is, I don't know.
It's expensive.
Yeah, it's expensive. Like, I don't even know how to put
Yeah.
it into words. Like, that just seems like a very large thing.
Right.
And that happens. Like, they miss that. Like, oh shoot, I
Yeah.
misjudged the number of people by 1,000. Like, how
Yeah.
does that
Maybe
happen?
not so much by 1,000, but
Okay.
what we see in the industry is architects are busy. And so when they're doing the code consulting life safety, they might look at more generalistic approach. They might take the square footage of the whole floor and assign a load to it. And it's 150 square foot per person on this floor. So you take the square foot of the building or of that floor, you take your 150 square foot per, you divide it out and you say, hey, I've got 1,000 people. Cool. I just need 2 staircases. Okay. But when you start looking at it, there's some conference rooms. That there is like a break room. That's an assembly space. You have classrooms over here. Those are loaded tighter than 150 square foot. 150 square foot is a pretty good space.
Yeah.
So when you're in a classroom, you are elbow to elbow. You're loaded more like 20 square foot per person or 15.
Yeah.
So if you've just taken the generic floor and assigned 150 square foot per person for the area, you will have a lot less occupants than in reality you have quite a bit more.
Interesting.
Because you have rooms with different uses. You have
Yeah.
assembly space. Yeah, you have.
And that's why that RFI portion is so critical for you, because that changes everything about the way you design it.
Yeah. And the
If those
furniture
numbers are
layout.
going to change.
You might call a
Oh.
room a meeting or an office, but if I see that there are 3 or more chairs, that is now assembly use. That's a collaboration space. And that gets loaded differently than your traditional business.
Interesting.
Yeah. So when you walk into the Five Guys and you look on the wall and it says 100, do not exceed 113 people, occupants.
Yeah. Yeah.
So how they arrive at that number is the building sprinklered or not? Probably not. What is the building built out of? Is it built like a Chipotle where it's all wood, or did they build it like like a strip mall where it's like steel? So it's like non-combustible construction. How much of that space is the business space, the like resident or the people eating, and how much of it is the kitchen? So you're taking your square footages of all these different areas, the different uses. Hey, I've got a big storage area back here. That's loaded differently too. We know in storage, you don't have a lot of people in a storage warehouse.
Yeah.
You don't need to account the same amount of people per square foot as you do in the restaurant. And so that,
and then your kitchen is a whole different beast too, because then you're dealing with lots of different flammables and different spacing and everything in there.
yeah.
Interesting. Okay, so then you go through all the design. So you've taken all of that into account. You've designed it in Revit. You've got everything there, and then you get to that point where you've done however many. What's the common number of iterations before you get to that? Whatever you called it, issue
for
when you're ready to
construction.
deliver it. Issue for construction. Yeah.
So commercial and federal are different, and they all have different ways that they go about it. If it's a really big project, you're going to have a lot more stages. If it's a small project, like a little 2-story bank, it's going to be a faster paced schedule. There's probably going to be less milestones. So typically you'll have like your these all have like acronyms. So you have DD or DD, SD, then CD, and so it's like I'm gonna butcher this. DD is pretty bare bones. That's your I don't even know, something design, and then SD is schematic design, and then CD is construction document. So each one, like you're a kid in school and you've got a rubric, you need to have this much stuff in your SD package. And then when you go from SD to DD, then you need to have this much more stuff for your DD package. And then from there to CD, you have even more. And at each stage, you're getting reviewed by other professionals that are reviewing and making comments or coordination items, or things are changing. Hey, we are changing the layout of this room. Scrap it. Let's do it again. And so those are like the official deadlines. Now, every company that is worth anything does internal coordination or quality control. So we call it QA, QC, quality assurance, quality control. And so I will have a person assigned to my project to just review what I've done at each like a week or two before each deliverable, so that they can look at it and say, oh yeah, that looks great. You don't need to change a thing. Or in reality, they're like, hey, these are the 8 things you missed. Let's work on that. So you're collaborating internally with your own business, your own team, to make sure that the best product is going out the door at each stage.
Interesting. Okay, cool. So then you deliver that package for construction, and then that gets sent over then to those like design engineers, like your job 4 years ago, to then further assign the material, get it ordered, get it delivered, and installed.
Right. So we have just completed the drawings. They went for permit. The city has reviewed them and approved them. We're good. You can start. You can start building. And there's different packages, so they probably already started the groundwork and everything. But the general contractor has hired out all his different subcontractors. And so they'll get our drawings and they'll start looking at it. And if they have questions, they'll send in RFIs. Hey, I don't really understand this. What does this mean? Oh, well, this. Whatever. Then they'll produce their shop drawings and they'll submit it to us for construction administration. We're going to look at it. So I drew the intent document, and sprinkler contractor A sends me their drawing, and it doesn't even come close. It doesn't match at all. They've totally missed the mark. It's like, what were they even looking at? Who knows? I am just going to hit it with a deny, reject it.
Okay. Yeah.
Do it again. It's just wrong. It's not meeting the code. This is a huge liability thing. You got to do it again. Send it back. Then they'll revise it and it comes back to you. You get to review it again. Anyways, you eventually approve it if it's right, and then they will. Now it's up to the general contractor and his scheduling to build that building. And I might go on site and review their work at different stages. And I'll likely be there at the end when they are commissioning the building.
That's cool. So does your stamp go on it then when you deliver it? Do that construction document, or does your stamp go on it after the next level designers have it all drawn out?
Depends on the state.
Oh, okay.
So in Tennessee, ours do not go on the shop drawings. Ours go on my construction documents. And then they will have their own stamp, not a professional engineering stamp, but something for in the sprinkler design world. Slightly different industry, similar, obviously, very related, different certification requirement. They'll stamp it and say, hey, this has been reviewed and designed by someone at this level. Boom, they send it in. So my stuff isn't going on theirs. There are some states where I have to review it and stamp it with my engineering seal and just say that I reviewed it.
Okay.
It's just state to state.
Yeah. So let's take that Tennessee example, and then going back before where you said, there's this catastrophic fire, and they do an investigation. I'm assuming they look at that shop drawing first, or do they look at them kind of like at the same time and say like, oh, well, this shop drawing, he didn't include this piece that the professional engineer told him to, or vice versa, where this guy added a piece in. and the engineer did not? How does that typically work out?
Yeah, super complicated. Um,
Yeah.
I have been fortunate to not be involved in any buildings that have burned down at my design, so I don't
There
exactly
you go.
know.
Yeah.
But I read a lot of reports of like, oh, this Home Depot just burned down and whatever. Why did it
Mm-hmm.
happen? And I'm thinking, why didn't the sprinkler system put it out?
Yeah.
And usually, when you keep following up on it, you find out someone had shut the valve and they forgot they shut it, and the sprinkler system never operated. It's
Ah.
like, shoot. Well, who's getting in trouble for that? Well, it's not the engineer,
Right.
and it's not the guy
Right.
that
Because it was
installed it.
designed right. It's just
It's
somebody.
probably a
Yeah.
maintenance guy.
Yeah.
So it's going to be shared liability, shared responsibility. Um,
Uh-huh.
a sprinkler system is very effective when maintained and in service.
Mm-hmm.
The finger will probably not be pointed at you. It will probably be pointed at, hey, this owner bought this or is leasing this building. That building's been around for 80 years. When they first put in that sprinkler system, it was 80 years ago. Codes have changed since then, and it was more
Mm-hmm.
for manufacturing, which is a lower
Mm-hmm.
hazard. Now they're
Mm-hmm.
storing bales of cotton indoor. Okay?
Uh-huh.
It's much more flammable, and they didn't do anything about the sprinkler system. Well, how can you
Yeah.
point at the engineer or the sprinkler contractor at that point? That is
Sure.
the whoever is leasing the building space.
Yeah.
They have said, you can move in here, buddy. You can bring your stuff in here. It's their responsibility, and probably the tenant, to say, hey, I need this and this and this. And then
Yeah.
there are insurance companies, different than State Farm, that are at the factory level that are insuring buildings and are walking through and saying, hey, that's not adequate. That needs to change.
Mm. Mm.
Or your premiums are going up.
Yeah. Oh, interesting. Um, okay, so you kind of teased this a little bit earlier as well. Give me some things that, like, in your world, where you like walk around and see that the common man, we'll call him, wouldn't notice. Like, viewing the world through your expert eyes as a professional engineer, what are some things that you see that most people just don't even think about or don't even notice?
Really just annoying things like poor workmanship. I look at
Mm.
the fire alarm, I see, oh, that conduit is really, why did they bend it that way? It looks terrible. Or the
Mm.
paint's falling off, or it's crooked. Just like poor workmanship. Or why don't they have a pull station there? That's an exit. They don't have a pull
Mm.
station. That's not allowed. Or a sprinkler head. Wow, they built a wall with the existing system and they never modified the sprinkler head spacing to accommodate for that new wall location. So now you've got a sprinkler head way too far off the wall. Looks terrible. It's not adequate. And it's just like, oh gosh, that's terrible.
Yeah.
Or you'll be watching a movie and some guy will go he's at the bar and he goes in the bathroom and he puts his lighter up and he pops that sprinkler head. And guess what happens?
Yeah.
Every head goes off. And it's like,
All the sprinklers go off. Yeah.
in reality, that one head would go off. And that's it.
No.
Each sprinkler head is mechanically activated. And so a pull station is not going to set the sprinkler system off either. Or if there's a fire in the corner, the whole building isn't just going to drench with water. These things
Wait, back up. You said the pull station's not going to set off the sprinklers?
never. No.
No way.
No. Yeah, feel free. Go and pull one. Don't pull one.
I might. Well, now I
Buy
know.
one and pull it. See what happens. Nothing. That's tied to the fire alarm system. That is notification.
Okay. Alarm is different than sprinkler when you're designing that system.
Yeah, there's some nuance. There are some systems that can be activated with alarm, but
Uh-huh.
we're not even going to talk about those. Those
Sure.
are just way
Sure.
less common. So when
Yeah.
you're in the school and someone has pulled the fire alarm, you're going to just hear the fire alarm going off.
Oh yeah, I guess that's right. Okay, I've experienced that.
Yeah.
Then I just in your head, like you say, when you're watching movies, they got to get everybody
Yeah.
out of the building, so they pull the thing, and then it starts raining on
Yeah.
them.
Yeah,
Yeah,
not going to happen.
you've ruined a lot of movies for us today.
Yeah,
so be aware of that.
Yeah, there's there's that. But yeah, you've got a fire. That sprinkler head, well, if it gets hot enough, it literally pops this little element, and then water pressure, which is already in the pipe, now has a hole to go out of. So it flows through the sprinkler head. That's it.
Yeah.
And it doesn't stop until you go to the main valve and you shut it off. There's a wheel, and you got to spin it. Shut it off.
Okay.
So there is no, oh, turn it off real quick. No, it's going to flow for 30 minutes or so, and you're going to have water everywhere.
Till the fire department gets there and turns the thing. What's a fire riser?
That's the main. What is a fire riser? A fire riser in a building is where you can control the fire sprinkler system downstream of it. So you can shut it off. There's all the things on it, right? There's like check valves to keep the water in the pipe. There's valves to shut the pipe. There's drains so you can drain down the pipe. There's flow switches, so when the water is flowing, the fire alarm goes off. So they are tied together just to tell you that there's a fire and to notify the authorities. So that's a riser.
Cool. That's a riser, because you see them like in buildings where it's just like fire riser, and it's like just like a metal door or something. And it's like, I don't know what that is. I just assume that it's supposed to be there. I guess
it's a wall of fire.
Yeah, what the heck? Okay, cool. Last couple of questions here. We're kind of running out of time. Start with a nightmare day. Give me just a picture of like today was a bad day. Give me like the things that happen that make it a bad day, and then follow that with a perfect day. Like you get home, you're like, this was a home run day.
Yeah. So a nightmare day would be you have done something wrong and you don't know about it. It wasn't negligent. You didn't just choose to do something wrong. But let's say you've just missed something. You've missed a portion of the code, and now you have a design that's wrong. And so now you have to change it. You have to get people involved. You got to fix it. That's a bad day. Another bad day is a day where you just can't get any work done because you're constantly being interrupted with meetings or phone calls or other problems on other things that need addressed urgently. And you just get pulled off all the time. You're just banging your head against a brick wall over and over again and can't do anything. Those are terrible days. Those are the days where it's like, what am I doing? Like, this is terrible.
Yeah.
A good day is when you get a lot of work done. You can sit at your computer. You have very few meetings that day. You're able to focus. You can get your designs done. The product is coming together smoothly, and you have solved a complicated issue for your client or the architect. That feels really good. Hey, maybe other companies can do it, but like these guys just got it done for us. That's a good feeling.
Yeah.
You feel important. You feel like you've contributed to society. You feel like you've done your job well, which is rewarding. So a good day is when everything goes right and you're just really just able to work. That's a good day. It is amazing how many meetings and things interrupt you and prevent you from just doing your job.
Yeah. Just so I can get some perspective on the whole process. You've been in the field for 9-ish years. Do you know how many buildings that you have worked on that are completed, that are done, that are in use?
Yeah. Probably in the consulting, in the last 4.5 years, probably 50, 60, 70 buildings.
Wow.
And then
that is way higher than I thought.
In my first, it would probably be close to that too. So maybe all in all, over 100 buildings.
Wow. Okay. That is genuinely surprising. I thought it was going to be like
5,
30 or less. I thought because we know how long construction takes, but I guess.
Yeah. So
I guess, like you said before, you're doing so many at the same time that they almost finish in batches, I guess, where it's like, 8 buildings got finished this year.
Yeah, that bad day is when I've got 2 projects that have a deliverable on the same day. That's a bad day.
Yeah. All right. Cool. So let me ask you this. This is my bonus question. I like to ask this at the end because it kind of gives us a kind of a look back perspective on you and your approach to work. So I like to phrase it: what gets you out of bed in the morning? What is it that gets you going, keeps you going?
I I like the industry. I think whether I'm working at this firm or another, I would stay within the fire protection industry and design. It is really fun and exciting to start on a building that doesn't exist and couldn't exist until you have worked on it, and to see
Mm.
it through from a dirt lot to a completed building that will be there for a century. That is
Yeah.
really exciting. You get to actively change the cityscape. Doing
Mm-hmm.
high-rise buildings in Nashville or in Cincinnati, you are literally changing the skyline,
Yeah.
and it's very fun and it's unique. So you don't meet many people that do the same thing as you,
Mm-hmm.
and there is something new every day. I am not designing a Chick-fil-A every single day. I've never
Yeah.
designed a Chick-fil-A, but you might be working on Chick-fil-A one day, and then you're working on a complicated code consulting question of, hey, I've got this historic building. What is its
Mm-hmm.
construction type? I need to add on to
Yeah.
it. And then you may, from there, work on a big storage warehouse for batteries. Technology that hasn't fully been understood at the fire protection level. And so you're
Mm-hmm.
working through these different challenging things all the time, and it's just a changing industry, and I love it.
Awesome. Awesome. Well, that's Connor Bailey, fire protection engineer. I appreciate you taking the time and walking us through all that. I'm sure there's so much more detail that could be gone into, but for to respect your time, we'll go ahead and call it there. And I appreciate you. Thank you so much.
Thanks, Josiah. Talk to you later.
All right. Talk to you later.